In this second chapter, we're going to get into actual 3D work with inside of Maya. In this chapter, we'll learn how we can create primitives such as cubes and spheres and scale them, move them, rotate them to create some compositional scenes that we can stretch our legs in Maya. But first, we're going to go over 3D principles, 3D design principles in the digital space, such as what polygons and things of that nature are. So why don't we go ahead and get into the components of a polygon. So I'm going to go ahead and bring up Maya right here. So we've kind of seen just a regular old primitive like this, but I've mentioned polygons several times in the last chapter. So what is a polygon? Well, a polygon, I'll just duplicate this cube and we'll make a single polygon out of it. A single polygon is just a flat shape like so. It has three different components that help define its dimensions and shape. The first component is the flat face itself. The second component are the edges around the polygon. And the third component are the intersections of these edges called vertices. Having control over these three components of a polygon mesh, a polygon model, are the foundations of creating polygonal game models that we'll use in future games and that you'll be creating throughout the rest of the course here. So let's look at some complex polygonal geometry and see how these polygons can be stitched together to create some interesting shapes. The very first thing we'll look at is this low poly, meaning very few polygons, low poly spaceship that we've created. We can see that we have multiple flat faces all stitched together to give this shape form. You can get an idea that the ship is kind of like a barge, a trading ship that carries maybe raw minerals from a mining colony. So already with this basic shape, I'm already given this model a background and its own lore. And so with that background, our model and our polygons that are stitched together to create this polygonal mesh need to be able to tell a convincing story to support whatever intention you have for your model. Uh, let's look at some polygon types right now. So I'll go ahead and bring up a cylinder like so. And by polygon types, I'm basically referring to how many edges a single flat shape polygon shares. 4 edges of this rectangle face of the cylinder is what we're going to be striving for throughout the rest of the class. So notice how each face has nice and spaced out 4 edges that make up the polygon. Triangles are another type of face that we'll be working with in polygonal modeling. Sometimes they can't be avoided, and whenever you import game models into a game engine, the model is tessellated, meaning its geometry is transformed into triangles anyway. So even if you import a polygon full of nothing but 4-sided polygonal faces, in the end, it's going to be turned into nothing but triangles as well. Then we have a polygon that we should avoid at all cost called the n-gon. And I'm going to create an n-gon right now so you guys can see what I'm talking about. On the bottom of this cylinder, we say a polygonal face that is an n-gon, meaning any polygon with more than 4 sides. So this polygon has 1, 2, 3, 4, 5, 6, 7, 8, 9 different sides. That creates a lot of different errors whenever we start modeling. All right. So whenever you go into sub D mode by pressing 3 on the keyboard, 1 and 3 switches between regular modeling, low poly modeling, and sub D modeling, we can see that the top, while not completely flat, does have, or not completely organic, does have a somewhat smooth shape to it. We still see a little bit of ridges caused by these triangles right here. But if we go to the bottom where the n-gon exists, we see that those ridges and those shading errors at the bottom here are even more pronounced. So in the world of polygonal modeling, Any shape with more than 4 sides is bad. And you can create an n-gon, basically, if you're not careful, by just not paying attention to the edges that a face has. So by deleting that single edge on the cylinder, I now have an n-gon with 6 edges. So one of the stipulations on the grading rubric for your modeling assignments is to avoid n-gons at all costs. And if I see an n-gon, then it will eventually count points off towards your final grade for that project. So n-gons, faces with more than 5 sides, are terrible. Don't do them. So why don't we get rid of this shape and just bring back in just a normal cube, like so. So why don't we talk about transforms or transformations? This is a topic or a word you'll hear used several times throughout the process. And transforms basically refer to its physical position in the 3D space that we talked about last chapter. Now, transforms can mean translations, such as moving it up, down, left, and right. And you can see in my channel box over here that after I've moved my object around, that we now have values in the transform box over here in my channel editor in the translate sections. Translate is another word for position. Okay? Another type of transform that models can have are rotations. All right, so that's the rotational transform. And the last will be scale. So scaling on any axis and in any direction is another type of transformation or a transform. So why don't we see how we can snap polygons to different places within our scene. So I'm going to go to modify and I'm going to reset the transformations. So I zero everything out on my cube. And now it was shaped as it was originally created. And why don't we see how we can snap objects to the grid and snap objects to other vertices on other models. Okay, to snap things to a grid, we have two methods in which we can enact snap to grid. We can come up here to our status line right here, and we can click the magnet we see right here. As you can see, it says snap to grids with a little tooltip there. So with that turned blue, now anytime we move my mesh, it snaps to the intersections that we see on my grid here. All right, for a keyboard shortcut, we can hold down X and snap ourselves. And when we release X, we can see that the magnet up here can go toggles on and off. So if you need to quickly snap something to the grid, you can just hold down X for X-ray and just snap it to a grid, like so. I'm going to duplicate this real quickly. And now we can see how to snap something to a vertice. So if I hold down the V key or select toggle snap to point that we see up here, or hold down V for vector on the keyboard, I can snap my model to the vertices of my cube here. And I'll turn wireframe on shaded so we can see the intersections of these edges and see the vertices on this cube. And by holding down V for vector, I can snap to the four corners of this cube because vertices live here. These little verts right here. All right, so that's how we can snap objects. X for the grid, V for vertex. And that'll come in handy whenever you're working in future projects. So I'm going to go back to modify and reset the transforms on this cube. And why don't we talk about the rules of a polygon? I've touched on them and probably mentioned them before, but all polygons must be composed of 3 or more vertices. If a polygon does not have, why don't we duplicate this and just, or I'll just create a plane here. All right. And with this plane selected, or let me recreate it, technical difficulties. So I've created this plane. So what we can do is we have 4 vertices. Now we deleted one and we're left with 3. And whenever you try to delete the third vertice, you'll see a warning from Maya. Some selected vertices have complex edge attachment. That's just meaning that vertices or models can't have more than one vertex. Look what happens whenever I snap this vertex to another vertex. Basically, all we're left with is a line. And this is what we call a hidden face. Okay? So hidden faces consist of polygons that only have two vertices. And this is a huge modeling error, and it will be one of the pitfalls of modeling that will be deducted against you if I ever see any uh, zero length faces. Basically meaning there's no width to them, there's zero length, and the face basically does not exist. So we'll get rid of that. The next thing we're going to have to assume is that flat faces should more or less stay flat. So what does that mean? Well, if I take this vertex and pull it out like so, now we have a flat shape that is somehow not flat anymore. Notice how our flat shape kind of has like a little crease right here, or it's a little weird bend. This is what you call a vastly non-coplanar face. For the most part, all faces should be planar, meaning they are flat, like so. See how from a front view, all of our faces are flat, but as soon as I select the vertex and pull it out like right here, I now see that I have a non-coplanar face. And sure, this can be fixed by bisecting the face and making it a triangle. And we've turned this non-coplanar four-sided face into two planar triangles because that triangle is flat and this triangle is flat. And by the very definition of how polygons are made with the vertices, all triangles will be completely flat and planar because you really can, no matter how much I move this vertex, that triangle is going to be flat because three vertices are the minimum to create a face. So there's no extra vertices like we see here on this corner of the cube to stretch out and make this once flat face right here non-coplanar. And this is a good angle to see the errors that we see here. We have like this bottom edge right here, and all of a sudden it just explodes out at a weird angle, and modeling and shading errors will start to incur. So let's undo everything we've done and get back my normal cube. Control Z will do the undo. Another thing that polygon meshes must have are closed shapes, like so. There are some rules of thumb that we will be able to break with this, but for the most part, when a polygon is open like this, or when a polygonal mesh is open like this, it could cause errors in the model itself. So for instance, what if we created a sphere? All right. And we have a face that we delete, but then we want to plug that hole up. Let me go back in and zoom in on that face here. Let's say we extrude this edge and then snap these verts. And then we've basically fixed the sphere back, and now it's whole again, right? Well, when I do a smooth on it, press 3 on the keyboard and smooth it out, we can see that the topology, or the way the lines wrap and flow around the model, are big problems right here. They don't sync up anymore. And honestly, this face right here, this means it's a open polygon. So when I move the edge or move the face, we can see the hole in the polygon. So something like this with the top missing from the cube is pretty easy to catch. But something like this where the face, I can't even remember which one it was, but when the face looks like it's complete and stitched over to its adjoining faces, but it's not, then we start getting errors in our polygon mesh. And lastly, let's talk about edge sharing. So I'll delete these and bring back a normal cube. And why don't we extrude an edge like so? This is another big no-no. This is no rule of thumb. This is the law. A single edge on a polygon mesh can only share two faces. So from this angle, we have one face, two faces connected to this edge. But if we look down here, we can see a third face right here connected to it. And whenever we do another smooth, look at that shape. Look at that modeling error. Very not good. But as soon as we delete that face, our cube turns quite nicely into the sphere when we press 3 on the keyboard and go into sub D mode. All right, so that does it for the rules of a polygon. Everything I just listed here will cost you points on your final grades for your assignments if I see those types of mistakes. And this mistake is so common that I had to give it its own place on the outliner, and that's overlapping faces. So basically, an overlapping face is whenever we have two faces that are connected to the same polygonal mesh that are over on top of one another. And to demonstrate this, the most common way we have overlapping faces is when we do an extrude face, and then we don't do anything with the extruded face, and we forget about it. And then we kind of go over and do something over here. What I've basically done is I've made an extra face on this cube here, but we can't see it because it's completely overlapped on the face below it. But we can reveal it if we press 3 on the keyboard here. And instead of a sphere now, we have a top or an acorn looking thing. So if I select this top face in sub D mode and press 1 to go back to regular cube mode, then we can see that that overlapping face is the exact dimensions of the face below it, or the faces around it. But what we don't see are the edges or faces around that face. So I've selected the little edges around the center part on the top here. And when I go into one mode, guess what we have? We have zero length faces. So that's really bad. We can also extrude again. And now we have even more shading errors. Now we have basically 3 extrusions on the same face. So that is very bad to do. And you can see that when I pull up that face, then we have, those faces are zero length, and now we can see them. So let's talk about hidden inside faces. And every once in a while, there will come a time whenever we duplicate across an axis, whenever we're modeling just one side of a model here. Let's delete that face. And then we want to mirror it across to the other side. So let me just set that up. I'll freeze my transformations. I'll reset them. And then I'll duplicate and do a negative scale in that direction. And then what we're going to do is we're going to combine these meshes. These are the techniques that you'll learn in future chapters. I'm just showing what kind of things can lead to the error I'm showing. And then we'll merge those verts together. And it looks like the shape is all well and good until we, again, smooth it by pressing 3 on the keyboard. And what we're left with is a hidden inside face inside of our model. That face right here. So if we zoom in, we see that we have a face, and this breaks the no edge can share more than one face rule. So we have one face, two face, and then over here we have 3 faces, all connected to this edge right there. And inside hidden faces will make your models look pretty bad. So we just have to select that face and delete it. And it looks like we had overlapping faces as well. So I select one face, delete it, and I still have a face in here. So I had 2 faces sit on top of one another. So by deleting both of them, we fix the modeling error. like so. And we still have some zero length faces right here. So I'll select them in sub D mode and then go back and press 1. Now we have zero length hidden faces around the edge of my polygon. So those are some pitfalls that you'll constantly be finding. And the easiest way to check for them is to press 3 to switch to subdivision mode. Subdivision mode is basically a quick way in which we can apply a smooth on an object. Basically increase its geometry and find the average of these new faces that are being made. So we create a very basic shape and then we just smooth it over and over again till we have something that's a little bit, more organic. And we'll be touching on sub-D modeling throughout each assignment. We won't be focusing on it too much, but we will be demonstrating it every once in a while. So why don't we go over what topology is? All right, so I'm going to go ahead and delete this guy, and I'm going to bring in a human figure, like so. All right, topology, like I mentioned earlier, is how edges flow across our model. And the way that the edges flow across our model actually gives us detail to our model here. So you can see I have a very, simple expression for the musculature of this human male figure. And that's because my topology swings around, kind of comes up here. And if I mess with the polygons a little bit and mess with the topology, so it did have a nice little flow to it. But as soon as I kind of mess up the edge flow here, like so, look what happens to the shape. We kind of get it's very subtle, but we start getting weird shading errors on our model. And it can be more pronounced the more that you mess up with the edge flow here. So even though it kind of still mimics the shape of our human, we're starting to see creases now because our edge flow isn't quite as smooth as it was before. So let me undo that. So if you're doing any kind of organic modeling, this nice, smooth, flowing edge flow is what's going to give you those nice, organic, smooth shapes that we see here. Why don't we also talk about what poles are? So good edge flow means that you can trace the edge all the way around. You can follow it like it was a road with no forks in it at all. And a complete edge loop with proper edge flow, if you double click its edge, it'll select the edge loop that's continuously running around the torso of my human. But there will come times in complex models where edges have forks in the road, such as this pole right here at the pelvis of our model here. It doesn't necessarily mean that it's a bad model anymore. It just means that we have to be clever about how we handle these crossroads of our edge flow here. Because if I'm following the edge up my thigh here, I come to a crossroads right here. I don't know whether to go left, right, or forward or back. Basically, I get a nice little fork in the road. So poles will exist on your model, and that's basically where edges come to either a point of 5 edges connected to a single vertex, like so, or just 3 edges connected to a vertex. I don't know if I have any 3 edge connections here. What is this? That's another 5er. Basically, a pole is any vertex intersection with more than 4 or exactly 3 edges connected to them. All right. So we can see a few poles in my eye here. Here's a pole. Here's a pole. There's another pole. And they're just going to occur in your models. All right, so that's a little bit about topology, and you'll learn more about topology as you get your hands dirty with models. You'll start seeing how edge flow affects how light reacts with our surfaces and how they dictate the nice shapes of our models. So let's talk about poly counts real quickly. I'll go ahead and hide my human over there. And I'm going to bring back my spaceship and bring up this high polygonal model we have here. And before I reveal the topology of the shotgun, we're going to activate or reveal a tool that'll help us see our poly counts. So we'll go to Display, Heads Up Display, and we'll click on Poly Count right there. Poly Count has a bunch of useful information with it. How many vertices, how many edges, faces, how many triangles. So faces include four-sided faces and n-gons that are in your scene, hopefully none. And tries tell you how many actual triangles these faces make up. So you'll always have more triangles than faces because it counts a single four-sided face. It'll count that as two triangles. And UVs are a component for texturing that we'll talk about towards the end of this course. So the very first column shows how many of each component are in the total scene right now. When you select something like the ship, the second column shows how many faces, verts, and edges exist on the model that you currently have selected. So this ship has 535 faces, 1,064 triangles, and this many edges and verts. So that's a useful little tool to have at your disposal. So let's talk about low poly, such as this model with 535 faces, versus a model like this with 262,000 faces that we see here, with even more triangles, 524,000 triangles. This is what you would call a high poly model, much like we were pressing 3 on the keyboard earlier to see the errors in modeling. We will figure out ways in which we can model this ship that whenever we press 3, it keeps its same hard edge design, but yet has more subtleties to it. So if we look at this gun here, we can see that edges like this that should be really sharp that on our ship, with high poly modeling, instead of it being sharp, the edges just kind of flow naturally over it. See that nice little topology here? And I'll select one of the edges. See this nice edge flow around what should be a sharp edge? And with the powers of high polygonal modeling here, here's another edge that should be sharp, but it's beveled out a little bit. It's got a nice round to it. With certain hard surface subdivision modeling techniques, we will be able to create more detailed models like so that have a higher polygon count. But you would not import this into a video game. What you would do is you would make a low poly version of it and then bake all the details, such as this groove and these little barrel holes right here, and even these screws. You would bake that information into what you would call a normal map that tricks the surface, the flat surface of this little flat area on the gun here. It would trick it into thinking that a screw was casting shadows on it, thus giving the illusion that there's actual depth on our model when none exist. So that is a modeling, end of modeling 2, modeling 3 concept of high polygon modeling, and using this as a way to bake the information onto a lower poly model. And since we are in a simulations and game development program, we're not going to be doing too much pre-rendered screens and screenshots for our program. We're always going to be striving to get our models and environments and characters running inside of a real-time engine. And the difference between that, a real-time engine and pre-rendered, is if I do a render here, this single frame took 3 seconds to render. Could you imagine a game running at 1 frame per 3 seconds? No. Typically, games would be running at 30 frames per second. So we have to optimize our models and not have so many polygons like you see here, so they can render at lightning fast speeds so we don't get slowdown within games. So those are some basic principles and rules of 3D design within the digital world of Maya. Why don't we switch gears and look at some actual tools that we can use to manipulate primitive shapes, such as cubes, spheres, and cylinders, and what have you. The first tool we'll look at is the Create menu. This tool, or rather this menu, allows us to create our primitives. And so we can create a cube, we can create a sphere, we can create a cylinder, we can create a cone or a plane. That's the cone I wanted. So we have all these basic shapes, right? Well, not only can we just simply create these basic shapes, if we wanted to add a little spice to them or make a cylinder with more faces, I will go and select cylinder, but instead of just clicking on the name, I'll click on the extra square menu right here next to it. And this actually brings up another window before I can create. And here I can describe how big I want it, such as its radius, how tall I want it, and how many axis divisions or how many faces circle around my cylinder. So let's make one with 30 axis divisions right here instead of just 10. So I will create it, and now I get a cylinder that's a lot more organic and more round. Same thing. If I go to sphere and open its extra options window, I can create a sphere with only 5 faces in each direction. And what we get is something close to a tetrahedron, just a really blocky 3-dimensional shape. But yet it's still a sphere. And on the flip side, I can go to that same sphere creation menu and just do 100 faces on the axis and on the height. And what we get here is a completely organic and round high poly sphere versus this really simple sphere. Both of these primitives were made with the same menu, the same window. So explore the extra menus and you can see kind of basically the components and the ways you can make your shapes here. Why don't we talk about a few more complex shapes real quickly? Uh, Cones and cylinders are explanatory. Torus, we can look at the torus here and we can rotate it up. And why don't we look at in our channel box and go to our attribute editor? Why don't we look at, and then we're going to click our way to Poly Torus 1 right here in our attribute editor. I got to there by clicking on my object. And if you have the channel box open, you'll just double click the attribute window right up here. So within this attribute window and selecting Polytorus 1 like so, I can begin to define this shape as well by moving these shaders or these sliders around. So I can determine how thick around it is, the actual width of it, the radius. I can determine its twist. So basically, I can determine how these edges are flowing across. So if I do a small twist, let's look at that edge right there. And then when I twist it, we see that the edge travels this way. Subdivisions allow you to make a shape such as that, like a prism almost, to a pentagon shape, and every which way in between. So again, to get to that menu to start editing the properties of a complex shape, such as the torus, we will double click my attribute window, and then we will find the tab that says Poly Torus 1. And why don't we look at the helix and see how we can use the attribute editor in the same way? Well, there's a pipe and a helix. The helixes are pretty cool. So I'm in my channel box. I've created my helix. And with my helix selected, I'll double click my attribute editor button right up here at the top, right there. And then I'll find poly helix. And here I have the same kind of sliders, but they do different things because my shape's a little bit different. I can define how many coils are attached to my helix. I can define how stretched out it is with height, how wide it is, how much space we have going in between it, the radius, so I can make it super skinny or super thick. I can add more polygons with subdivision axis. I can add more polygons in the other direction. And I can even define how many polygons get put on the end cap right here. Or I can even give it a rounded cap, like so. So it's pretty cool stuff here. All right, so that's how we can create primitives and use various attribute editors to give them different properties. Why don't we look how we can select objects within our scene exactly the way we want to. I haven't really gone over selection yet, so I'm going to bring in a few different shapes here. Why don't I bring in a pipe this time? So we have basically a cylinder with a hollowed out inside. So I have a few different primitive shapes in my scene now. And as you guys might have guessed, that if you just click something, then you're going to select it. Even with the move tool selected over here, see how it's blued out? Even with that selected, if I still single click something with no other buttons pressed, it'll select it. But if I press Q on the keyboard, then I just get a simple selection error with no transformation handles, like so. All right. If I select this pipe, I get the pipe. If I select the cube, and so on and so forth. I can even drag a box around models, and even if you just barely kiss the bottom side of this pipe here, it'll still select the whole object here. All right. So why don't we see how we can hold down Shift and Control at the same time, Shift and Control, and I can single click that. And notice how my cursor is a plus sign. That means I can additive select now, like so. If I wanted to unselect one of these but keep the other two selected, I can just hold down Control by itself and click. And now I've unclicked that cube by holding down Control. And if you hold down Control, you can see a little minus sign over your cursor. So if we hold down Shift and Control, or just rather hold down Shift and drag a box around all of these models, I'll select the inverse. So whatever is selected will become unselected, and anything that was not selected currently right now becomes selected. So it's an inverse selection just by holding Shift. So single click with no other keys is single click, single selection. Shift and Control held down together is additive selection. Control held down is negative selection or subtractive selection. Shift by itself is inverse selection. So why don't we look at transformation tools? Remember I was talking about moving and rotating earlier, and I was kind of just doing it without exactly explaining how I was doing it. And if you've seen it before, this will be just a quick review here. The best way to do it is to use the keyboard shortcuts on the keyboard. So Q on the keyboard, Q for quasar, will just open up your selection cursor. W for Winston will bring up your move handle. E for echo will rotate your objects. And R for Robin will open up or change to the scale transformation handle. And again, each one of these transformation handles can either be moved with the middle one selected in the middle, and it can be moved in any direction or rotated in any direction or scaled uniformly. But as soon as we start selecting the colored bits on the ends of these handles, we start moving and rotating along certain axes. And I can only go left and right. I know that's a bit of a review. I might have gone over it in the last chapter, but just hitting the topic again, because you'll be primarily using these move tools, scale tools, and rotate tools to complete your assignment. So why don't we talk about a little bit more about the channel box and the transformation values that we see up here in the top right corner of the screen. So I'm going to clear out all the models on the screen here, and I'm going to snap my cube straight to the center of the grid by holding down X. All right, so why don't we talk about freezing transformations versus resetting transformations? And before we can talk about that, we have to give this cube some brand new transformations. So I'll move it up here, I'll rotate it along all axes, and I'll scale it across all axes. All right, so what we have now is a channel box in the top right corner up here that is full of a bunch of different numbers. That's because we've messed with the transform values in all three areas, such as move, rotate, and scale. So why don't we look at some new tools called reset and freeze transformation. All right, and I'm just going to demonstrate them and we can get an idea of what they do. So if my model is in a weird position and I want to get it back to the original state it was when it was created, when it was last had its transforms frozen, I can go to modify and reset the transformations. And if you'll look, not only does my cube become fresh and new again, the values over here in my transform window all become zeros and one. So I call that zeroing out the channel box, zeroing out your transforms. Let's undo that. And why don't we look at and see what freeze transformation does? So I'll go to modify and freeze transformations. Basically, what freeze transformations does is it keeps the position, the rotation, and the scale the very same, but yet my channel box has been zeroed out. So it's basically saying that this is the default position, rotation, and scale for this shape now. So if I come over here and start messing with it again, like so, and then I do another, this time I'll do a reset transformation. It takes it back to whenever I froze the transformations earlier. It doesn't take it back to the cube anymore. So I'll make another cube and I'll show that again. So when you first make a cube, it sits at the very center of the grid and everything is zeroed out in the transformations window right up here in the top left. But as soon as you start moving and rotating this object, then you start adding new values to your X, Y, and Z transforms. All right. So I'll scale it in that direction. So all reset does is it resets these values back to 0 and 1. So I'll modify and reset the transformations. And it takes it back to its original state because at its original state, it was 0 and 1. But as soon as you freeze the transformations of an object, then you're saying that this is the new default position and shape and rotation of the object. So if you make any other changes and then try to do a reset again, it goes back to your newly created default transforms for the object here. And that's useful for numerous reasons. And you'll be using transform reset and transform freeze quite frequently when you start learning how they're used in various workflows here. So after we were messing with our freeze and reset transformations, we now have our transformation handle at the very center of the grid, but yet our object is kind of out in space away from the center of the grid. So what that means is our pivot point is now far away from our original object. So if we rotate it, we're going to rotate from this arbitrary point out in space now, and we're going to scale it from out there as well. And it's going to be moved from out there. So anytime that your handlebars get out from the center of your object here, we can go to Modify, Center Pivot, and here they are, sitting nice and pretty. Okay, so we got the center pivot, and why don't we talk defining a custom pivot point for our objects. So I'm going to go ahead and create a new cube, and my shelf seems to have disappeared. So I'll go to Window Display, Heads Up Display, or UI Elements, and Show All UI Elements, and bring that back. So I'll create a new cube, and let's say I wanted to rotate from the very bottom of my cube. Well, I just hold down D for dog, and I can start moving my pivot point anywhere in space here. I want to do that. But let's say I want to be able to pivot from the very center bottom, like this center face right at the bottom of my cube here. Well, I'll hold down D for dog and V for vector, and just move in the y-axis. So select the green arrow and pull it straight down. So what I'm doing is I'm setting the axis point while snapping the vertices, but only snapping in the y-axis. So that brings down my pivot point right at the bottom of my cube here. So if I go to a front view like so, you can see that my new pivot point is set right to the bottom of my cube. All right. Or you can just define it by dragging it anywhere. But using a snap tool and only using a certain arrow in one direction will still snap your pivot point, or anything that you're trying to snap. It'll still snap it to that vertice, but it will only snap it along that axis. So you can see I'm holding down D and V, and I'm snapping back and forth. If I was just to snap by just dragging it from anywhere, then it would snap directly onto that vertice. But by just holding down one single axis handle, I can just snap in that axis according to the same, line it up with that vertice in the x-axis. So with all this talk about transformation values and freezing your transformation and center pivots and custom pivots, let me show you how we can use all these tools in concert to do a pretty cool little trick with an object. So I'm going to create another cube, or let's do yeah, we can do a cube. That'll be fun. And well, actually, I want to create a shape that has some pizzazz to it, so I can see see what happens whenever I mirror it. So I'll create a helix. Okay, and I'll double click the attribute editor and go to polyhelix, and maybe turn down its radius real quick because it's a little too thick. There we go. So with this helix selected, I'm going to position it over here and up here. Well, what if I wanted to mirror it directly across on the other axis? Well, that leads us to our next tool we'll be using as well, called duplication. To duplicate this, I'll have to have it selected, and then I can go to Edit and Duplicate. And it doesn't look like anything happens, but what it does is it creates another object on top of the coil. And if I bring up my outliner here, let me go to Edit, Delete All by Type History. Delete all by type history here. We can see that I have helix 1 and helix 2 right here in my outliner. Helix 1 and helix 2. I can select helix 2 in my outliner, and now I can actually see, yeah, I have 2 helixes. But it's a one-to-one duplication. What if I wanted to have a mirror image of this coil spring? Well, I can select my helix, and I can duplicate it. And then what I can do, I can go over to my scale, and I want to duplicate it in the X direction. So I'll give it a scale value of -1. And what we get is a mirror image. See how it's completely mirroring my coil here? And that'll be an important trick we learn in the future whenever we're working on one side of our models. And you'll see me use it in the assignment example I will be completing very shortly. So we've talked about duplication. Why don't we talk about duplicate special? So to duplicate special, I'll go down to edit and there's duplicate special right there. But I'm going to make sure I always select the extra menu option so I can get my duplicate special menu to come up. And this gives us a bunch of different tools to duplicate with. Here I can either create a exact copy or an instance of that model. A copy means it's its own separate mesh, completely unique in every way. If we do a duplicate special instance, oh, I've just created 100 versions. If we do an instance of my helix, look what happens whenever I start messing with the vertices. Since this is an instance of this object, and vice versa, all the changes I make to the topology, not to the scale, not to the rotation, but to the actual edge flow, get mimicked on this model as well. So an instance duplication, special duplication, is pretty handy sometimes. I'm going to switch it back to copy. And what we're going to look at now are some of the special ways we can use some transformation settings to create some interesting effects. I can modify, oh, wrong. I can freeze those transformations and reset those transformations to bring my pivot point to the center of the map. So now I kind of have a rotation outside of my coil. I will rotate in the, looks like I need to rotate around in the y-axis. I'll rotate 15 times, about 15 degrees for every duplication. And I'm going to create, let's say, 7 copies. So every time that it creates a duplicated copy of this coil, it's going to rotate it 15 degrees, and it's going to make 7 copies by doing that. So what we get is a cool little arc of helixes. And again, if I wanted to create a row of helixes, the first column is always the x-axis. The second column is always the y-axis. The third column is always the z-axis. So anytime you see a value of coordinate positions right here, this applies to Maya, Unity, anything with a coordinate system, X, Y, Z. Pretty self-explanatory. But I can move my helix by 4 units, and I can create 68 helixes. And that's a lot of helixes. So duplicate special gives you some pretty interesting options to use. So I'll get rid of the duplicate special menu and let's talk about the outliner here. I'm going to open up a brand new scene so we get a fresh outliner. And I'm going to create some cubes here. And we're going to show how I can, or some various shapes. And make a little cone. There we go. And we can show how we can use my outliner to organize my scene here. And scene organization is going to be one of the parameters in which I'm always grading your work. So it'll be very important to pay attention to this part. So we have a cube, a cylinder, and a cone. What I'm going to do is I'm going to give everything I create, or most things I create in my scenes, their own name. So I can call this cube mesh 001. I'll use all lowercase actually, cube mesh 001. And call this cyl mesh 001. And call this cone mesh 001. When you start creating your work, you're going to have models that are just going to have, by default, some pretty terrible naming conventions. And whenever you pass off your work to somebody, or when you're going back to your scene and you're trying to find that one specific table lamp you made in your big house that you modeled, you're going to have a tough time navigating your scene. But that's where our outliner comes in handy. And we can get to that by going to Windows and Outliner. You can double click something to rename it. You can reorder things by holding down middle mouse button and then positioning your arrow right between 2 other objects. You can even parent one cube or one object under another by middle mouse clicking and dragging on top of that. So now our cone mesh is the parent to our cube mesh. So if I select my cone mesh, it's like a little kid and its parent. The kid's going to follow that parent around wherever it goes. And that'll be useful for creating custom groups, grouping things in your outliner. What we can do is if I want to group together all of my rounder objects in my scene, I can select my cylinder and my cube. I can go to Edit and press Group. And now I have a new group that I can expand and collapse. They're still their own object. One does not control the other, but they're grouped up under the same kind of collapsible and expandable menu here. And I can call this round shapes group. And if I select the group in the outliner, then I can control all the objects under this group here. A keyboard shortcut to do this, let's make a few cubes here. So notice I have a cube mesh 001 and cube mesh 002. I can press Control G and group those together and call this cube group. So creating custom groups with edit and group, or I can select both of these groups and just make a monster group called shapes in general. And I can expand that. Here I have the round shapes and the cubes, all parented under shapes. So organizing your outliner and naming everything is going to be something that I'm going to be looking for in all of your scenes. So if you want to have a more permanent coupling of two objects, you can actually just combine them together into one complete object. They won't be merged physically in any way, but they will be one object for all intents and purposes. If you say, for instance, you selected it on the outliner. So I'll select both of my cubes here and go to Mesh and go to Combine. What I'm left with is a messy outliner though. My cube group now has these two empty groups in them with transform 1 and 2, and they don't really do much. So I'll go to Edit, Delete All by Type, and go to History. Now I got rid of those messy groups that were empty, and I have a new cube mesh, and it'll give it the name of the first thing you selected, I believe. It'll just give it a name that you probably don't want to use. So we'll call this double cube mesh 001. So now that I've combined these two, no matter what I do, they're going to be rotating and scaling and moving together as if they were one flush object. If you if you want to undo that, but you can't do it with Control Z, the undo function, you can also use the mesh separate, and it'll take every watertight or completely flush individual object that has been combined together, and it'll separate them again. So now I can move my cube separately from one another. And in here we have another transform ghost value here. So we'll go to Edit, Delete All by Type, History. And we have my two cubes now with just generic names attached to them. So we'll call this cube mesh 001 and cube mesh 002. And let's discuss one more organizational tool before we get into maybe doing an example of the assignment, so you can see maybe my workflow process of using primitives tools that I've shown you so far. What we're going to do is we're going to create layers. And in my channel box, you want to bring your channel box up. So if you're missing it, just click your channel box icon at the top right of Maya up here. Like right there is your channel box tool or window toggle. And under your transform values that we've been working with right here, we have a layer menu at the very bottom. And there's two ways we can make layers. We can create a new layer, a new empty layer with the plus sign right here. Let me zoom in a little bit better. With the plus sign option right here, and the toggle with just a circle makes a layer with any selected objects you have. So let's make an empty layer, and we're going to call this round shapes layer, and there we go. Uh-oh, warning. Maya does not like spaces or weird characters within a layer name. So we're going to have to call it round underscore shapes underscore layer. And there we go. And we're still messing up. Round underscore lay. There we go. So this layer is empty, meaning there's nothing in it. So to populate it, I'm going to select all the round shapes I have, because this is my round shape layer I just made. And I'm going to right click on layer, and I'm going to add selected objects. So now, whenever I toggle the visibility, V for visibility on my layer, I can hide them at will. Very nice. If I want to remove one of the objects from this group, I can select whatever object I just put the layer. I can select whatever object I just put in the layer, and with that object selected, I go to remove selected objects. Now that cone is no longer part of the layer, and only the cylinder is able to be hidden. If I want to add it back, select it, right click, add selected objects. If you accidentally make one too many layers and there's nothing in them, you can go to layers, delete unused layers. If you have a layer that you want to get rid of, like you don't want round layer anymore, you can select it like so, and you can go to layers, delete selected layer. Now we're only left with this random layer I just made. And I think I want to delete as well. So delete unused layers, or I can go to delete selected layers. Why don't we show how we can create a layer that are already populated with things we have selected. So I have no layers. I'm going to select my cubes here. Okay. Or I can select the group that my cubes are in my outliner. If I click on the circle layer tool right here, it'll create a new layer and call this cube underscore layer. And guess what? I didn't have to add them because they were already selected when I use the create layer with object selected button right here. Okay, so that's a little bit about layers, and I'll just do the selected with selected again, and then round lay. And there we go. I now have two layers that I can control. And not only can I make them go invisible, but I can also make them go into wireframe mode, like so. Or I can completely lock them out. When it says R, they're shaded, but they're completely locked out. I can't select them. I can't go and select any of the vertices or anything. I mean, I can do a select all, but that's about it. Even if I move them, there we go. I can still move them. But I can't drag a cursor around them or individually select them. So I'm safe just to kind of drag a cursor around the whole scene. My cube layer is locked, so I can't mess with my cubes. Same thing here. If I lock every layer in my scene, I can't mess with anything just by selecting them. I can still select them in my outliner, but as far as selecting them in the scene, they are locked out. And that'll be handy whenever you get a model to the point where you like it. You can just put it on its own layer and lock it out, and you don't have to worry about accidentally selecting it anymore and messing it up. So with these tools and organizational methods introduced, I'm going to go through and make a quick little robot using nothing but primitive tools. He's not going to be anything special, but I will demonstrate some of the techniques I like to use when creating models themselves. So I'm going to go and create a new scene. And what I'm going to do is I'm going to make sure before I start my assignment, I'm going to go to File, and I'm going to go to my project window and set a new project. So I'll go to New. I'll name this project Robot. I'll pick where I want to save it. And for this point and purpose, I'm just going to put it on my desktop, and I'll do Accept. If I go to my desktop, not only do I have a robot on my desktop, but now I have a folder called Robot with all of the folders that we'll need when creating our scenes. We even have a folder called scenes, and this is where all of your Maya scenes are going to be saved as you're working on your assignments. And after I create my project, the first thing I'm going to do next is go to Save Scene As, and I know I'm going to be making a robot, so I'll go ahead and save this scene and call it Robot, like so. So you can see at the top of my Maya that I'm in Patrick Desktop Robot folder, my Scenes folder, and I'm working under robot.ma. Also note that I saved as a Maya ASCII. Maya binary is default. I prefer saving as Maya ASCII because it allows you to go into the Maya file itself in a text editor and edit different values that allow you to maybe use a newer version of a newer scene made in 2016. Cannot be opened in 2015, but it can if you go and tweak the .ma file. So I'll go to my scenes folder right here, and I'll open with, choose a default program. Well, actually, it'll be faster to open up Notepad and then go to File, Open, Desktop. There's my project folder I just made. Let's go into my scenes. Let's go select all files. And I can actually open my Maya scene and see everything in my scene so far. And this part right here requires Maya 2016. I can actually change this to Maya 2015 and hit Control S and save it. So now I can open this file on a 2015 version of Maya. So that's why I prefer .ma. Let's get rid of that render. So I got my scene made. Now I'm going to make the body of my robot first. So I'll go to Polygon, Primitives, and let's start with a cube. And the video is getting a little long, so I'll kind of go through this somewhat fast, but I'll explain everything clearly what I'm doing. And I'm not going to make too much of a complex robot. So I'll create his little block body here. He's going to be more of like a little robot toy, or I don't know, just a little Tin Man guy. And I've moved it and I've scaled it the way I like. So my body's going to be kind of, rectangular shaped. And I'm good with this position. So I'm going to go ahead and freeze my transformation. So go to Modify, Freeze Transformations. And I'm going to go to Windows and bring up my outliner. And I'm going to call this Body Mesh 001, like so. All right. So why don't I duplicate this cube with Control D, and I'm going to make, I don't know, some abs, little toy abs for my robot. So I'm going to duplicate the body with Control D and just make little abs that are coming out here, maybe make them skinnier, bring them in a little bit, and do something like this. But you'll see over here in my outliner, my ab is called Body Mesh 002. So we'll call this Ab Mesh 001. And whenever I duplicate this ab to create his six-pack, I'll bring it down like so. You'll notice that with this naming convention, it went ahead and called it Ab Mesh 002. So that's pretty useful for the way that you name things in your outliner. So there's his little abs there. Nothing to write home about. I'm going to give him some pectoral muscles. So I'm going to select the body again and base his pectorals off the body. So I'm going to scale this in, bring it up, scale it in a little bit more, maybe scale it in the X direction. And I think I made it a little too small, so I'll scale it from the middle. There we go. There's his little armored pectoral. Make it a little bit bigger. Maybe make it come out a little bit more. I don't want to give him rubies, which are robot boobies, of course. So what I'll do is I'll position it exactly like this. I'm going to make sure it's on one side of the grid. And I'm going to go press 4 to go into wireframe mode. So I quickly tap spacebar to go to 4-quadrant view. And then I press spacebar on the front view. and I'm noticing that my pectoral was coming over to the right side of his body. So one was going to be bigger than the other, or they wouldn't fit. So there we go. I'm positioning it just so in my front view. I tap spacebar and go back to my perspective view. So I'm going to show us a technique where we can mirror the pectoral exactly across in the same position on the right side without having just to do a Control D duplication and then kind of eye it, because that's not exactly mirrored. It's close, but no cigar. So what we'll do is our first step to doing a mirror duplication is to position the object the way we want it. And then we want to go to modify and we'll freeze our transformations, meaning we'll zero out our channel box over here, but we won't mess with the position of my pectoral robot muscle because I like where it's at. So what this does is it allows me to do a modify reset transformations. And now my pivot point is all the way down here. So my pivot point is right on the center part of the grid right here. So if I do a duplicate, then the duplicated cube's pivot point is going to be down here as well. So that'll help me set up the mirror duplication trick I'm about to show. So I got the object exactly where I want it. I got its transformed zeroed out, zeros and ones. I've got its transformation handle right at the center of the grid. So I will name it first, actually. So I'll call this Pec Mesh 001. So after I've got all these things done, I will duplicate it. So I got Pec Mesh 002. And since we're zeroed out in my channel box and my transformation handle is at the very center of the grid, if I give myself a -1 scale value in the scale X position, that means I'm going to create the same object, but its position and its properties and its location is going to be mirrored across the duplicate axis. If I didn't have my crosshair in the middle of the grid, this is what would happen. So I'll hold down D for a custom pivot point, D for dog. I'll do the same technique. Control D to duplicate, give it a -1. And look, it mirrors it across wherever your handle is. So that's why we did a reset transformation, so we can get that handle right in the center of the grid. So I'll duplicate it again and redo my work here. Do a -1. My handlebar is right at the center of the grid. And now my pecs are mirror duplicated across the zero axis because I paid special care to where my handles were, my pivot point was. Now I'll select both pecs and go to modify center pivot. So now my pivot point's back where I want it, right in the center of the pecs here. So why don't we add some rivets down the sides of my robot here? So I'll create a new cylinder. There we have this huge cylinder at the bottom. So I need to do a few things. This is going to be my first cylinder that I'm going to create a rivet for, but I'm going to create multiples. And I'm having trouble getting the cylinder completely perpendicular here. So I'm going to go to my channel box over here and see where I'm rotating in the z-axis. It's not quite a 90-degree angle. So I'll type in 90, -90 and get it exactly turned the way I want it. And then I'm just going to scale it down. And I'll bring it in like so. And why don't we add some rivets down his middle of his body. So before I start duplicating though, I'll call it rivet mesh 001. And I'm going to reset its, or freeze transformations. So I've zeroed out my channel box. Why don't I use duplicate special now to duplicate a new rivet every few little bit. So let's move it. We want to move downwards in the Y direction. So why don't we do a -0.5 in the Y direction. And let's see what 5 rivets look like. So every time I duplicate, I'm going to move 5 units, -0.5 units down. All right. It was a little too much, so it might be a trial and error kind of deal here. So I'll hit Control Z to undo that duplication. And why don't we pick a smaller value like negative 0.25? And there we go. I got the rivets completely made for me and positioned exactly like they should be. And in fact, I might select them all in my outliner and move them up just a tad bit. And with these rivets selected, I'm going to, you know what? I want to mirror duplicate this to the other side. So freeze those transforms, reset those transforms, do a duplication with all of them selected, and give them a -1 and the channel box. And in those few steps does the mirror duplication just right for us. Working in the center part of your axis is a pretty important part of the workflow process. It helps you do mirror duplications really easily like that. So now I've got all these pieces of my body made. My outliner is a complete disaster. So what I'm going to do is I'm going to select all of these models here. I'm going to press Control G and group them. And let's call this body group, GRP for group. And with my body group selected, I'm going to create new layer from selected, like so, and call this my body layer. So now I can lock my body layer down and I can't mess with it at all. All right, great. So why don't I go ahead and continue working on my robot? I'm just going to create a few more things for him. So I'm going to make his little head like right here. And I'm going to call this head mesh 001. And I'm going to give him some donut eyes. So I'm going to create a torus. Here's my little torus here. I'm going to start to rotate it upwards like I want it. But I'm going to make sure it's completely 90 degrees in my channel box over here. I'll scale it down. And that's still a big eye, so I think I need to scale it down a little bit more. And here we go. I like where that eye is at. Maybe scale it down a little bit more. So I'll do a modify, freeze transformations, modify, reset transformations to zero out my handlebar here. I'll Control D to duplicate that. Actually, before I do that, I'll name it iMesh 001. Control D to duplicate that. So I got iMesh 002 now. And then I'll give it a -1 in the X axis scale. And I got a completely mirrored over eye. All right, so there's my head and eyes. I'm going to create, what should I give him for his mouth? Let's do a prism for a mouth. So to position this prism just the way I want it, I'm going to rotate 90 degrees along this axis. And I'll refine that 90-degree movement in my channel box. And then I'll rotate it 90 degrees over here. And then I'll scale it and push it exactly where I want it. So there's this little speaker box mouth. It's almost like a little stereo. That's pretty cool. So there's this little mouth. Did I make another prism on accident? I made 2 prisms on accident. So I'll call that mouth mesh 001. Perfect. I'll select all of these parts of the head. And since my body is locked, I can just sloppily select everything in the scene because my body is locked out. Control G. Now I have a head group like so. And we're starting to come along with this little guy. I'm going to select my head group and give it a new empty layer and call this head layer. And then I'll hide it. Wait a minute. I didn't do create layer from selected. So with my head group selected, I'll right click on my head layer and I'll add selected objects. And since I'm a little OCD, I will keep the same kind of capitalization conventions here. I don't want a capital H and a lowercase b. That's sloppy. So there's my head locked down. All right, great. So I'm going to give him a quick little arm. So I'm going to go to create and make another cube here. So I'm going to make his little shoulder pad. There's a little shoulder pad going on right here. All right. And I want to call this shoulder mesh 001. And then I'll create a cylinder. And this will be his arm. And he's not going to be a very articulate robot. He's just going to have an arm that comes straight out. So I'll do a negative 90 degrees there. I'll scale it down. I'll press F to zoom in on it. And we'll scale that out. Bring it out. And what I'm going to do next is set a custom pivot point so I can scale. Right now, if I scale in the Y direction, it scales from both sides of the cylinder. I don't want that. I just kind of want to put the arm in its socket and just grow it out from the socket. So I'll hold down D for dog and V for vector and hold both of those down. And then I'll drag and drop that pivot point right here in the middle of my cylinder. So I'm snapping the pivot point to the vertex in the middle of the cylinder. So now, when I scale, I'm only scaling from one side. So I'll plug that right in there. And what I'll do is call this arm mesh 01. I'm going to duplicate my shoulder to create his hand. So let's go back to perspective. So I'm going to kind of center this cube right at the end. There we go. There's his little hand. So we'll call this hand mesh 001. And I'm going to make a little claw grabber for him. So I'm going to make it out of another cylinder. So his claw hand will be made out of cylinders. Claw mesh 001. And since I already have the pivot point right at the base of the cylinder, that's pretty lucky. Being able to configure this like a finger should be okay. I'm going to bring it in just a little bit, pull it back some. There we go. And then I'm going to control D, and I'm going to snap this second part of the claw with snapping with my vertice. So V, I'll be able to snap to the verts of that little cylinder there, and then I'll be able to rotate it in on this axis. So there's a little claw there. And I need to give myself the other side of the claw. So how am I going to do that? If I just duplicate them and then, well, the rotations are going crazy now. So this is an instance in which combining two objects together would be very beneficial. So we'll go to Mesh and do a combine. I get these weird extra little empty groups. So I'll go to Edit, Delete All by Type, History. And we'll call this Claw Mesh 001. And then my pivot point, when I combine something, gets reset to the center of the grid. So I'll go to Modify. Where's Center Pivot? Center Pivot, like so. But I want to bring my pivot point back at the base of my claw. So I'm going to bring it out a little bit. I'll hold down D and hold down V. And now I can give myself that custom pivot point again. So I'll just place it back where I want it. I'll hit Control D. Now I can rotate it exactly the way I want it. Or I could give it a -1 scale in the X direction and just do another little mirror duplication. So there's an arm for him. He's very angry looking. So I'll select all of my arm pieces, Control G to group it, and call this arm left group. And duplicate it again and call this arm right group. And what we'll do is we'll give, since I duplicated this and combined it already, my group, I can just give a -1 scale to the whole group of the right arm, and it'll scale everything inside of that group for me. That's pretty cool. So my left arm group has a +1 scale on the X over in here on the right top side. My right arm group has -1. And that allowed me to mirror it across, because when you group something, its transformation handle is automatically set to the center of the grid. All right. So what I'm going to do next is I'm just going to unlock everything. And I like the position of everything. And every once in a while, when I'm satisfied with the position of a model, with a few models, I'll select all the meshes in my scene, all the primitives, and I'll do a modify, freeze transformations. I'll even select the groups in my outliner and make sure that their transformations are frozen as well. So it's basically making them the defaults. These positions and scales are the default shapes for all of these guys right now. So I'm going to select both arm groups and go to create layer with selected objects and call this arms lay. And we'll lock everything out. All right, cool. So to make things go a little bit faster, I'm going to show us how we can repurpose things. So I'm going to duplicate these arms again. Actually, I'll just duplicate one arm and work with it to make the legs. So I'll come down here. And what I'm going to do next, it looks like I need to take this arm group. It's still part of the, it's going to become my leg. So I'll call this leg right or leg left group. But it's still part of my legs layer. So I need to select the group, right click on arms layer, and remove selected objects. So now my little arm that I've duplicated and I'm going to turn into a leg isn't so much, part of the legs group. So what I'm going to do is I'm going to use this as the base of my robot. So I'll bring the little claw down there. And then I'm going to combine these two guys right here. Actually, I'll make the cylinder a little bit longer since this is legs. I'm going to combine these two together. Mesh, combine. And then I'm going to hold down D for dog, V as in vector, and snap the pivot point to the bottom of that cylinder again, and just rotate it up 90 degrees and position it like so. So I've turned the arm into a foot basically. But my ball joint, well, that might be okay. Let's see. Oh, what do we got here? We got those empty groups again from using the combine tool. So I'll go to edit mesh, delete all by type history. And I'll rename this new combined layer to thigh mesh 001, or tight if you want to go tight. There we go. And now I can spell. And I'll middle mouse click and drag and drop it into my left leg group to parent it back into the main group. So I'll select my left leg group now. Oh, and its pivot point is just crazy out of the way. So with my leg left group selected, not the individual components of it, but rather the group itself, I need to go to Modify, Center Pivot. Now I can have a better idea of where I want to put this leg. So with the whole group selected, I can do something like this. And I don't want to cover up that rivet, but I definitely don't want to give myself hardly any space to connect. And then my leg is situated the way I like it, but I have some messy outliners or messy channel box going on. So you guessed it, modify, freeze transformations. In fact, I'm just going to freeze all the transformations in this leg all at the same time. And we're going to do a duplication on left leg. We'll call it leg right group. and we'll do a -1 scale on the X. Oh, but it didn't push it over to that side. What gives? Well, that's because we need to reset our transformations. So I'm going to reset my transformations on my left leg. See, leg, I got to rename it. So now that the transformations are kind of reset for the right leg, I can do the -1 duplication and it put it right where it wants to go. All right, so that is my 20-minute robot that I made. I expect you guys to spend a little bit more time on the project, but this little demonstration was kind of show you guys what's going on. Well, now I need to select both legs and give it a leg layer. So don't forget to pay attention to your layers over here. So that's my little robot. What I'm going to do now is I'm going to save as and call this robot final. And by calling it robot final, like so, that means that's the file that you want to degrade. And also, don't forget that as you're modeling along with this, that anytime you make an important change, let's say you wanted the legs to be a little bit taller, so you scale it in that direction and bring it down, and then you actually have to take your claw part and bring it down. And then I want to kind of redo the thigh there. Well, I like where that leg's at, so I'm going to do a file, increment, and save. And then I'm going to reset these transformations, or freeze the transformations, and then duplicate the leg. Make sure I reset the transformations before I do a -1 scale. So that's leg right group. And then after that's done, I'll do another increment and save. And then this is actually what I want to submit. So I'll go to save as now, and I'll overwrite robot final. And you can see I have 2 incremental saves right here that kind of served as the checkpoints I just made using increment and save option. So I'm going to overwrite my robot final though, because this is what I want the professor or the instructor to actually grade. So this is what I want to turn in for my assignment. So I can close the scene down or minimize Maya. And here is my project folder, robot on my desktop. So what I'm going to do is I'm ready to turn this into Moodle. So I'll right click on it and I'll send to a compressed zip folder. And then before I turn it in, I got to name it. So I'll call this rotor underscore Patrick underscore chapter 02 underscore SGD 114 for the class name. Then I can use this zip folder right here on my desktop. I can actually, that's what I'll submit to Moodle with the correct naming convention that I just used. All right, guys, thanks for watching. I hope you guys have fun messing around with some basic shapes and getting used to duplicating and layering and organizing your outliner. Thanks.